GitHub Advanced Security plays a crucial role in enhancing the security posture of software development projects on GitHub. It provides a comprehensive set of tools and features designed to identify and address security vulnerabilities throughout the entire development and DevOps lifecycle. Welcome to this course on GitHub Advanced Security, where you will learn how to tackle these real-world security scenarios. By integrating security directly into the end-to-end application lifecycle management process using GitHub Advanced Security, your team can build more secure and reliable software. To illustrate how exactly this works, I'll walk you through 5 different modules. Depending on your experience level with GitHub or the GitHub Advanced Security feature specifically, you can go through the content chronologically or pick out the specific modules that will be most beneficial for your learning. I'll kick off this course with an introduction to DevSecOps and GitHub Advanced Security, mainly setting the scene on what the features are about, as well as positioning some licensing aspects. In the second module, you'll learn about several GitHub security best practices, helping you to protect and secure sensitive data, as well as configuring security policies for your code repositories. From there, we'll jump into the more advanced pace, covering the different capabilities of the GitHub Advanced Security plan, starting with Dependabot vulnerability scanning, covering secret scanning next, and then closing with a somewhat larger module on CodeQL, which is GitHub's solution for overall code security scanning. My name is Peter Ditender, lead technical trainer here at Microsoft since summer 2019. Initially joined the European trainers team, but managed to relocate to Redmond about 4 years ago to continue the role out of the Americas. Out of my role, I've been mainly teaching Azure architecture and Microsoft DevOps solutions, with a good mix of developing Azure solutions. And then over the last 18 months, this shifted more heavily to Azure AI, and as you can see, GitHub course portfolio. Before I moved into the full-time Microsoft role, I was already running my own business for about 10 years, with a main focus on providing Azure and Azure DevOps consulting and training workshop services to global Microsoft customers and partners. Outside of work, I still like to share knowledge with technical communities through book writing, conference speaking, or blogging. And when I'm not at my computer, I'm most probably experimenting with baking or taking a walk to burn all the calories from that baking. I'm happily sharing my contact details here, so feel free to reach me by email or ping me on Teams, petender@microsoft.com, or maybe you want to stay connected through LinkedIn, and that's linkedin.com/in/PDTIT. While I hope this video course content will help you understand the different GitHub Advanced Security features, where I'll use a combination of slides together with an extensive set of live demos, know that you can continue your own learning at your own pace and in your own time using our Microsoft Learn platform. The baseline content used for these videos is split in 2 different parts, reachable from the following URLs: aka.ms/learn-gh-500-part1 and part 2. There's a total of 8 different modules, which then got consolidated into 5 different videos. Now let me take you to the Learn platform and show you a bit of what it's about and how the content is organized. So if you follow that aka.ms/learn-gh-500 part 1 or part 2, remember there's 2 parts here, the webpage looks a little bit what I'm showing here on my screen. And the idea is that obviously you're going to use this as companion material to the videos that you're already watching. Thanks for joining. And just want to share a little bit of typical use case for our Learn platform. So it's basically reading through material. And as you could find out from the agenda, we have different modules. Now remember, we have 4 different modules here in part 1 and then 4 other in part 2. But out of the video series, we consolidated the 3 CodeQL modules in one single presentation. So the idea is that you could start with any module that you want, And then from here, as you can see, there's different sections. At the end of each and every section, so let me open up just one of these. Again, it's basically reading through material, and a lot of this is identical to my presentation part, but then also to make sure that we're not making super lengthy videos, we're also pointing back to that learn material, which allows you to go through in your own time and whenever you want to do this. At the end of each module, you typically have our module assessment, basically a few sample questions. Now, I have to say this is really useful to just reflect on your own knowledge, like what did I learn out of this module? But to be honest, I don't think the level of detail of the questions is identical on the actual exam. So don't really, I would say, get fooled that if you manage to go through all these module assessment questions and you can answer all of them, that you're totally ready for the exam. But I'll talk about the exam a little bit later on. Then for a few other modules, let me pick out the second one here, configuring the PandaBot. Again, the approach is identical, but then you can see that over here, we also have an exercise link. Now the exercises, they're on the Learn platform. There's a lot of different variations. Some of them are embedded in Learn, where you're going to use Cloud Shell and you only need a Microsoft account. Sometimes it's just providing descriptions, where the assumption is that you do have your own account. And for these ones, since we're primarily focusing on GitHub, you can see here that we have a link to open the exercise on GitHub itself. So the assumption is that from here, you get redirected to GitHub. You need to have a GitHub account, where I would recommend a personal account, not using your corporate account to go through any of these, because maybe some permissions might block you, right? And that's a bit how our Learn platform is organized. A set of modules, reading through material, allowing you to go through in your own time, picking out the specific topics that you want to learn more about, and then the knowledge check questions or the module assessment. And last, for some modules, we do have those exercises. Another way to validate your skills on GitHub Advanced Security is taking the GitHub certification exam. It's targeting any individual who wants to validate a skill set on integrating, configuring, managing DevSecOps processes, as well as securing your GitHub repositories and using it in actions. You can find more details regarding the certification at this mentioned link, aka.ms learn GH-500 cert. Now let me show you quickly what information you can find on that page. So as I mentioned, there is quite some information, very useful information actually, to be found on that short link, aka.ms/learn GH-500 cert. That's redirecting you to this page, where you can see, obviously, this is all about our GitHub Advanced Security. The idea is to give you more insights about how to prepare for the exam, where the good news is that Part 1, Part 2, the ones that I showed you in the previous demo, is like the perfect starting point to get you through the certification. But again, remember that probably some practical experience going through exercises might be even more beneficial. And then obviously watching the videos, going through all of them that we have here, would also help you understanding and seeing quite some of those demo steps as well. Next to that, there is a link here to take a practice assessment. Now, if you go through those Part 1, Part 2 modules, you'll find out that a lot of those questions are, again, quite identical, but they're slightly different as well, to make sure that you're getting more ready to actually pass that exam. A little bit further down, you find the different exam domains. I had them in the video as well. So in short, shouldn't be really surprising. There's a little bit on what is GitHub Advanced Security about, what are the features, why should you use it, how to configure secret scanning, dependency management, code scanning, a little bit more in-depth on CodeQL, and then also describing more advanced GitHub security best practices, and then closing with some specific enterprise capabilities. There's more details about the exam itself. For example, here, quite important, 100 minutes to go through, so basically 1 hour and a half. And also important is the exam policy. What's relevant here? You need to have a webcam, you need to have a microphone, you're getting proctored, and the assumption here is obviously that you're going to take it from home, maybe from the office, but also make sure that it's a super quiet space, like no one can walk in, walk out the room that you're in to take the exam, and there cannot be any background noise. And I also think, but you might check once you schedule the exam, that you are now allowed to use a second monitor, but you might need to validate that. If you schedule the exam, but for whatever reason you can't take it because something's happening, work is requiring priorities, maybe something out of not feeling ready enough, you can reschedule the exam, but you need to do that, I think, 48 hours up front. And if you fail the exam, which happens, even myself as a trainer, I failed some of the Azure exams in the past, you can retake it after 24 hours. Now, typically when you fail, there's going to be a report. It's going to tell you out of the different domains, like these are your strengths, these are your weaknesses. And then probably you need a bit more time to go back to the modules, preparing a bit more, and then taking the exam maybe like the week after or again, whenever it fits. When you are comfortable with all of this information, you can eventually go through one of the last steps, and that's scheduling the exam. It's going to redirect you to Pearson VUE, which is one of the global exam centers that Microsoft is partnering with in this case. And they're going to offer you availability based on your location, your time zone, and anything else that's relevant there. If you do not want to take it remote, you can obviously still look into any local Pearson VUE test centers in your area where the proctoring is happening out of that facility. So it's slightly different. And then also the cost attached to it. So this is $99 US. And if you change to your local currency, you're going to see that the numbers might vary a little bit. And then last, what I want to emphasize is additional certification resources. So we provide you with a study guide. There is the broader Microsoft certification poster. If you go like, well, I want to do more GitHub certifications, I want to get more Azure credentials or Office 365 or Copilot, we got so many of them. That's where you can find more information. I hope that's going to give you enough reflection on how to prepare even better for the certification. And I think with that, I'm going to jump on to the next module. In this first session, Introduction to GitHub Advanced Security, I'll first help you becoming familiar with the concepts of DevOps and DevSecOps before actually positioning the different GitHub Advanced Security features as well as GitHub security best practices. It will allow you to identify critical areas for eliminating security gaps in your GitHub environment. Now, starting with an introduction, or hopefully for a lot of you developers, DevOps, maybe cloud engineers, it's hopefully more like a good refresh on DevSecOps. This module will help you exploring the different GitHub Advanced Security features as well as GitHub security best practices. Since it's the first module, I'm going to keep it a little bit introductory level, as the more technical details with more demos will get covered in all remaining modules. With that, I would say, let's get started. This is my placeholder slide to position DevOps and DevSecOps. I want to bring this in to avoid any assumptions that all of you are already up to speed on the specific topic. And since we don't have this as part of this specific module content in Learn, given the focus is obviously the learning path about GitHub Advanced Security, I'll use the whiteboard to walk you through some of those concepts. Now, when we think about DevOps, it basically starts with this kind of representation, which I describe as a continuous loop. I could also translate this to, once you start doing DevOps, you're gonna do just DevOps. Like, you cannot really pick out one of the sections. You cannot do like half of the work. It's basically, let's do DevOps within our organization. And it means you're gonna start with it, you're gonna end it, you're gonna continue doing it. From there, we're gonna detect different stages. The first stage is the planning phase. Planning phase is sometimes also known as the architecting phase, the brainstorming exercise. It's where you're going to think about what is the workload, what is the target runtime environment. So it could be a retail web application running in Azure App Services, connecting to a database in Azure SQL Cosmos DB, maybe a virtual machine, anything like that. Where then obviously the planning phase will help you identifying what are the platform characteristics, what kind of deployment scenario do we need, like integrating infrastructure as code, and then maybe adding project management, budgeting, and anything else that allows you to actually start working on it, building the DevOps team, allocating the sprints, allocating the deadlines, the milestones. That's all happening in the planning phase. And that's where it's also sometimes described as the project management aspect of it. Once we know what we're going to build, who's going to build it, how we're going to build it, and eventually where and how we're going to run it, it means that we can start working on the actual development, or what we call the build stage. We're now building or developing technically means we're going to ask our developers to create application code. We're also going to ask our infrastructure team to create infrastructure as code base. And then you could stretch this a little bit where we could have our AI team to integrate AI code. Maybe we have a database team to integrate some database code. So what's important here is that the development stage is not only expecting work coming from the developers. Once the development cycle is done, we're going to move on in our cycle, and this is where we typically see what we call a package. So if you run like a .NET build, for example, or integrating packages like out of like NPM or maybe Maven in the Java world, that's not the package I'm talking about. When you do like .NET build and .NET publish, it's creating an artifact, like a web deploy zip file, knowing that in this imaginary scenario, we're talking about creating, building, running a web application. From there, obviously, the package is what we need to run the actual deployment. So the next stage or phase here is deploy or release. And that's the stage that I describe typically as we move something into a running state. This is also where we typically identify different runtime environments like a dev and test, Q&A before moving into production. Deploying something into containers, Kubernetes environments, could be on-prem, could be cloud, could be multi-cloud. So that's really what we're talking about. And then we're almost done, where we're going to move to the last stage, and that's obviously our operations cycle, or maybe the management, monitoring operations, everything to make sure that the workload scenario we have is actually running healthy. And then from there, also important, we use some feedback loop out of our operations teams, providing feedback back to the planning team to, for example, revise it, like we have more users, more customers connecting to the workload. We need better high availability, disaster recovery. We're going to run software updates. There's more feature demand from the business or the users. And then from there, going through that, again, continuous loop. So that's in short, I would say, what DevOps stands for. Another little aspect from DevOps is how to automate all this. So what I'm talking about here is what some of you might already know is CI/CD pipelines. So using the same simplified diagram, there's basically two different cycles. The CI cycle is happening on the closer to the left side, maybe closer to the starting point, and it's basically situating here. In short, what it means is with continuous integration, technically it's a parameter, it's a setting in your trigger of your actions pipelines if you're using GitHub, or in your Azure DevOps pipelines, obviously, or any other DevOps platform. But since this is a GitHub Advanced Security course, I assume that you're also using GitHub Actions to run your pipelines. What we're doing in CI continuous integration is basically whenever a developer is creating an updated version of the code base, we're going to create a new package. Like again, creating that artifact, creating a web deploy zip or anything similar. And we're going to use automation and an automated trigger to do that. Every single time there's code updates, we're going to go through the build stage in a pipeline. Where then the second part, continuous deployment or CD, means that basically every time we have a new version coming out of CI, we're going to move it into a running state. And again, it doesn't mean move straight to production. So it's basically situating over here where we're going to grab the latest version of the package and we're going to deploy it into our target runtime environment. And then ultimately, if you're again familiar with CI/CD pipelines, it means that you're automating everything. From the planning phase through the development stage, deploying something into dev and test QA production, and eventually the operations team, monitoring management team is watching over. So that's, I guess, a pretty good introduction to DevOps. Little jump here into DevSecOps. Now what it means is pretty straightforward, I would say. We keep all the stages, but now we're going to add security into it. Now what that means is in the planning phase, we're going to think about security capabilities. For example, threat modeling. What about permissions? What about administrative permissions? What about access between the web app and the database? And so on and so on. In the development and build stage, we're going to think about integrating security where obviously, yes, quite some features from GitHub that we'll cover throughout this course basically fit in that development build stage. But you could also think about a broader scenario, like not integrating secrets, doing vulnerability scanning, maybe watching over who can develop what kind of framework scenario are we using. That's mainly what we're looking at. Then obviously the same on the deployment or release side, integrating all possible security features from the target runtime. Network layer, firewalling layer, load balancing layer, again, authentication, maybe passwordless credential, managed identities in Azure could be an example. And all that to still integrate security into the operations cycle. Now, if you look into more details on DevSecOps, you might recognize a term that we call that shifting left. Now, what that basically means is that if you look at our continuous loop from DevOps, where we have the 4 stages: planning, building, deploying, and operations, you could say historically, security was primarily happening here, like integrating networking, firewalling, user permissions, authentication, and anything else that I already mentioned. We're now with shifting left. We're not only thinking about security in the planning phase, but now we're going to make sure that we bring security into each and every cycle of our DevOps scenario. If you think about why is this important, I have a bit of a simplification, and there's obviously a lot more material, but we can talk about a 10x factor. So what it means is, imagine your planning phase starts with a cost of 100, which in the end is just a number. But it could be 1 hour of work, it could be a day of work, it could be a week, a month with the whole DevOps team. That's really what that number reflects. When you integrate security already in the starting point out of the planning phase, thinking about security in all following aspects, it means that you're pretty well covered. Where now, if we skip thinking, integrating the planning of our security baseline, it means that now this is moving up with a factor of 10. We forget about security integration out of the planning phase. We're going to build it, and that's where we need to mitigate. That's where we need to fix the problem. What it means is that the cost, which could be hourly cost, which could be obviously even actual cost for integrating tooling, it's just becoming a more expensive exercise. Again, if we skip thinking about security and not really thinking or integrating security protection during the build stage, again, during deployment, it becomes again 10 times more expensive. To eventually, if you don't do DevSecOps and you just rely on the sort of historical traditional approach to security, it means that now your exact same security vulnerability is becoming a cost of 100,000. So it's like 1,000 times more expensive to wait all the way to the end instead of integrating security into each and every stage. So from here, I hope I gave you a pretty well introduction. Again, I know it takes about 10, 12 minutes, but I hope it's still giving you a pretty good view, although it's a bit condensed. You can find a lot more information about the details of DevOps on the GitHub site, a lot more DevSecOps details on our Learn platform. From here, let's jump into the more technical modules, I would say, where every now and then during my demos, I'll try to refer back to this whiteboard story. So with that, let's jump back to our presentation. So now you have a good idea about DevOps culture, the main DevOps phases, and obviously where security is crucial in any of the stages that we then call DevSecOps. Let's make a shift to GitHub Advanced Security. Gone are the days when security was isolated and treated as a separate phase or even a gate in the software development lifecycle. As we learned, not doing DevSecOps may lead to delayed identification and delayed remediation of vulnerabilities if you already detect them, as well as issues are only getting discovered late in the development process. It can result in increased time and resources spent on fixing those security issues, which again potentially impacts the project timeline. In today's day and age, it's imperative that we integrate security seamlessly into each and every step of the software development lifecycle. This approach ensures that security considerations are getting addressed from the project inception, resulting in faster identification and resolution of vulnerabilities. GitHub Advanced Security can help with early detection, which allows for detecting vulnerabilities at the source code level, minimizing the likelihood of issues reaching production all the way at the end. GitHub Advanced Security can also help with efficient remediation. This means that security issues can be addressed promptly as part of your regular development activities, reducing the time and effort required to understand the actual context of the given issue. And then next, GitHub Advanced Security also helps with integrating consistent security standards. This ensures consistent alignment to your security standards across the entire development lifecycle, fostering a proactive security culture within your development team. In the end, GitHub Advanced Security empowers DevSecOps teams to prioritize innovation, enhancing developer productivity without sacrificing security. Automated security checks are run with every pull request, surfacing issues in the context of the development workflow, so vulnerabilities are fixed in minutes, not taking months. Now, what difference does the GitHub Advanced Security feature make in your application lifecycle? Let's have a look at this basic security scenario first. This example illustrates a traditional security as a gate approach, in which a single security test or maybe a series of security tests take place during the quality assurance phase. In this scenario, security usually ends up becoming a bottleneck to shipping the software. This situation is what your company most probably wants to, and maybe even needs to fix by what we earlier called shifting security left. Now let's look at the exact same software development lifecycle, but now using GitHub Advanced Security. In this scenario, security is set up right from the beginning through security policies, all the way at the project configuration stage. Developers then get alerts of potential security issues at every step of the development process, starting from code scanning, where the scanning for potential vulnerabilities and coding errors is occurring at every commit and merge. From there, we move into secret scanning, which scans at every commit and merge again, scanning for tokens, for example, private keys or any other secrets that maybe got accidentally committed. And then from there, it's followed by dependency reviews, which keeps track of the project dependency changes and their effect on project security. It compares the repository manifest files to the database of known vulnerabilities, again at every pull request. Now, using this specific approach, security incidents are getting captured during the build stage, long before they might creep into your production runtime. On top of that, it also removes the bottleneck during that Q&A stage, which overall helps developer velocity, which in turn means we're shipping application changes or maybe even full products in a faster way. But now, thanks to GitHub Advanced Security, we're also shipping it more securely. In addition, the security overview offers administrators a high-level view of the project security status. This view lets administrators identify problematic repositories that might require intervention. The main difference compared to the previous slide is that by using GitHub Advanced Security, the security of your code is reviewed multiple times before you get to the quality assurance stage, so there's less chance for a bottleneck right before shipping and obviously less technical debt. Now let's have a more in-depth look at the 3 core GitHub Advanced Security components, without again sharing too much detail, or there is nothing more to cover in all the other modules. Secret scanning is a crucial security feature designed to identify and mitigate the exposure of sensitive information, such as API keys and tokens within the source code. Secret scanning also includes push protection to proactively prevent secret leaks by scanning code on every commit action and blocking a push if a secret is present, as well as the ability to easily view alerts and remediating them without ever having to leave GitHub. Next, we have code scanning. Code scanning is an integral feature of GitHub Advanced Security that analyzes source code for security vulnerabilities and coding errors. It utilizes static analysis techniques to identify potential issues, like for example SQL injection, cross-site scripting, and maybe buffer overflows, to mention just a few examples. By providing automated feedback directly within the pull request workflow, code scanning enables developers to address vulnerabilities early on in the development process. And then last here we have Dependabot. Dependabot is a GitHub-owned automated dependency management tool responsible for keeping project dependencies up to date. It regularly checks for updates to libraries and frameworks used in any of your projects, and from there automatically opening pull requests to update dependencies to the latest, probably most secured version. Dependabot contributes to maintaining a secure and stable development environment by addressing vulnerabilities which are present in outdated dependencies. Another nice characteristic of GitHub Advanced Security is that it's becoming an integral part of that development workflow without requiring you to change your core DevOps processes. Even better, several security features are available for public repos, already available by design, where obviously the GitHub Advanced Security capabilities within a GitHub Enterprise Cloud provide even more comprehensive set of advanced features. In the screenshot here, you can see a little glimpse of the configuration on how to enable any or all of the security features. We're about to wrap up this first introductory module where I try to give you a quick overview of what DevSecOps is about and how GitHub Advanced Security gives you a full range of security features, helping in securing the full scope of your software lifecycle management. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search for your next favorite topic on Microsoft Learn using aka.ms/learn. I would like to thank you for having been here with me for this first section. There's a lot more to talk through, so allow me to invite you to join me in the next module, where I'm going to cover several GitHub security best practices, allowing you to secure your GitHub environment as well as protecting your repositories. I'm pretty sure I'm going to see you back soon.